Hey guys, welcome back. This is Frank, and welcome to our IGCSE COSI chemistry revision videos. So today we're gonna start a new unit, C5, Detective Chemistry, and this unit is mainly a very practical unit. So it has a lot of small experiments, and I do recommend that while you're watching my videos, try to search for like other videos, uh, with actual experiment. If you cannot do that in school, and because it's very very helpful to actually get a hands-on experience, or at least watch someone having and doing an experiment, so that you can have that idea, that visual representation idea of what's gonna happen. So yeah, as far as I can help, I can list all the notes and stuff like that, but I would still suggest you watch a very real life practical experiment for these points, to make sure that you have a full comprehension of the knowledge. But anyway, so as I've said, this unit consists of many small practicals. So we're just gonna focus on them one by one, and today our topic is going to be identifying gases. So uh, according to the IGCSE syllabus, there are five gases that might appear on the test, and they might ask you methods to identify them. So yeah, we're just gonna look at them one by one. So starting with oxygen, I'm just gonna do this here. So we know that the chemical symbol for oxygen is O2. Oops, is O2. So we're gonna test for O2. And let's think about some properties of oxygen. So how would you describe oxygen? Well, we know that it's the air that we breathe in every day. So we can say that it's uh a colorless, so some physical properties, and odorless gas. So yeah, it doesn't have a color. It's transparent, and it doesn't have a smell. Like you can quite smell oxygen. So yeah, we call it like colorless, odorless gas. And the experiment to identify oxygen is actually, if you light a wooden splint, like put it on fire, and then you blow it off, so that it's still lighted, it's still glowing, but it's not burning. And then when you put it in pure oxygen, it should be able to be relighted. So I'm just gonna write a short summary here. So it should relight a glowing splint. So hang on, let me see if I can get you a picture of what that looks like. All right. So, just so you know what a glowing splint and a burning splint looks like, this is an image from Wikimedia Commons. I've written a credit here. So basically, as you can see, a glowing splint is on the left, so it's like not burning, but it's not off, so you can still see the red bit over here. But like, yeah, it's not exactly burning, but it's still glowing. And this, of course, is a burning splint. So like, it burns very bright and with a fire, and yeah. So oxygen would relight a glowing splint. So if you put a glowing splint in like a very large amount of oxygen, you should expect to see something like this. But anyway, we're gonna move on and talk about hydrogen. So hydrogen, as we know, the chemical formula is H2. And pretty much like oxygen, hydrogen is also a colorless, odorless gas. All right. So well, you don't have to really have to say this, but like it is highly flammable, so it explodes very easily. But anyway, we're not gonna put that here on here, as it's not a physical property, I guess. So the test for hydrogen is, well, we put not a glowing splint, but a burning splint. Remember, like we just talked about like glowing and burning, and we put a burning splint into the test tube, and it should burn with a squeaky pop. So I'll write it here, burns with, so burning splint, and the identifying factor is a squeaky pop. So when you put a burning splint in hydrogen, it should give a squeaky pop when it burns, and it's sort of like a little explosion. It's quite cool. But anyway, moving on, we're gonna get carbon dioxide, so CO2, and well, actually CO2 is also a colorless, odorless gas. So colorless, odorless gas. And the test for CO2 is actually lime water. So you put, so if you have a test tube, right, you put a cap on, and then you have like a little tube to connect to the outside, and then you run it. So I'll write it here, bubble through lime water. All right, and hopefully CO2 would turn lime water milky or cloudy. So basically, what's gonna happen is that it's gonna make the lime water. The lime water is originally clear and colorless, and it's going to form white precipitate with the lime water. So it's gonna make the lime water turn milky. And I'm just gonna go find an image of this. Okay, so here's an image I found again on Wikimedia Commons of pretty milky lime water, and I think you can see that well the reason behind this is that when lime water or uh, CaOH2 or calcium hydroxide, this is lime water, when it meets CO2, which is a gas, it forms CaCO3 precipitate, so that's a solid, and if I'm not mistaken, water, so H2O, a liquid. So yeah, that's basically how the lime water test works, and yeah, it forms CaCO3, which is a white precipitate as you see, and yeah, it turns the lime water milky basically. Cool. So we're going to move on. We're going to move on to our next gas, which is ammonia. And we know that the formula for ammonia is NH3. So yeah, ammonia is actually well, it's still color. Oops, sorry, it's still colorless. Oh, just delete. It's still colorless, but it has a very pungent smell. So, ammonia actually, a lot of people say it smells like toilet, but well, you might not be able to put that on an IGCSE test, I suppose. But yeah, you can say it's very pungent smelling, and it smells bad basically. But don't use that. Don't say bad. Never say something is bad in chemistry because that's not proper language. Say it's pungent smelling. Anyway, pungent smelling gas. So the way we test for ammonia is actually we use a moist red litmus paper, and it turns the litmus paper blue. And actually, the reason behind this is that when ammonia, which is I'll just write it there. It's a very extension part, but yeah, when ammonia meets water, it becomes ammonium. So ammonium ion and hydroxide ion. So uh, it's kind of get separated into NH4 and OH, and we know that OH, which is hydroxide ion, is a base, so that's why it turns moist red litmus paper blue because it is alkaline or it is basic. So yeah, so using a red litmus paper we can test for bases. But anyway, that's just an extension, and I guess I really found it helpful. These kind of extra stuff that is not covered in the syllabus, but it really helps me remember kind of these results. So yeah, I mean, if it helps, it helps, and if it confuses you, don't worry about it. So just remember that ammonia turns moist red, litmus paper blue. Moving on, we have our final chlorine gas, which is Cl2, and uh, chlorine gas actually has a very greenish yellow, so green yellow color, I guess. Uh, and it is also pungent smelling, so pungent gas. So well, chlorine is basically what they use in bleaches and stuff. So you might see that in pools, and some people say chlorine gas smells like pool, and don't smell it because it's toxic, extremely toxic, and yeah, it might hurt your respiratory system, and yeah. But anyway, uh, a very decent amount of chlorine can actually kill many germs. So yeah, it's widely used in cleaning products and stuff like that. So you might see that every day. But anyway, never smell laboratory chlorine because you're gonna like probably feel dizzy, and hopefully you won't die, but that would also be possible. So don't smell it. Anyway, so it has a green yellow color, and it is a pungent gas. And the test for chlorine is actually uh, it's the opposite of ammonia. So it turns moist blue litmus paper red. And the reason for this is that well, this is also extension. I'm just saying that because it helped me memorize kind of the results of this test again. So pardon me, it is exactly the opposite as ammonia because let me write here. When chlorine uh or let's say chlorine ions, or actually chlorine gas, meets water, it becomes hydrochloric acid and hypochlorous acid. So HClO is actually called hypochlorous acid. So it's also an acid. Not, I don't think it's a strong acid. I think it's a weak acid. But anyway, it's still an acid. And we know that HCl is hydrochloric acid. So you have HCl and HClO, which are both acids. So that's why it turns moist blue litmus paper red. And just to mention that, the reason why these have to be moist litmus paper, and you need to have emphasize on that, is because without, if it's not moist, you're not gonna have the water, and actually water is a very very interesting substance. If you dig into it, it has a lot of interesting properties, including separating these guys into ions and stuff like that. So yeah, it has to be in water though. When it meets water, it does that. But if it's just dry litmus paper, then it will do nothing. So yeah. Anyway, that's all for today's video. We talked about oxygen, hydrogen, carbon dioxide, ammonia, and chlorine, the properties of them, and how you would test them. We also took a closer look at the different test results. So yeah, this is basically all you need to remember for the gas identification part. And that's all for today, and I hope to see you guys next week.